Coming at you from West Virginia. Welcome back, everybody. Okay, are you ready for joke of the day? Of course you're ready for joke of the day because it is the best part of the day. All right, what do you call a dinosaur with an extensive vocabulary? Well, a thesaurus, of course. Okay, let's extend ourselves into sum and difference of cubes. So sum and difference of cubes is a particular type of polynomial that can be factored. Now, I've said many times throughout all these videos, well, there's a pattern that you can memorize, but I don't have the pattern memorized and I'm not going to do it. There's a pattern that you can memorize, but you don't have to memorize the pattern. Unfortunately, sum and difference of cubes is a pattern that you most definitely have to memorize. There is no way of getting around it. But hey, if this is the only pattern you have to memorize, that's not too bad. So there's some ways to make the memorization a little bit easier, and for one, I use what's called a cube of soap, because soap comes in a cube, and so if you have a summary difference of cubes like you would see right here, notice this is a cubed term because this is A times A times A. Same thing here, cubed term, B times B times B. I have a sum of cubes. Here I have a difference of cubes. Difference means minus. So what I can do is I can establish the way my signs will be set up within the factorization. Now, whenever you have a sum and difference of cubes, the way you factor it is into a binomial and a trinomial. Binomial and trinomial. Now, binomial, remember, has how many terms? Yes, 2 terms. So I'm going to have 2 slots to fill in here, 2 slots to fill in here, and then a trinomial has how many terms? Yes, 3 terms. 1, 2, 3, and 1, 2, 3. Now, between these 2 terms, I'm either going to have a plus or a minus. Same thing here, either a plus or a minus, and same thing here, either a plus or a minus. The way that I know to fill in those signs is with this mnemonic, a cube of soap. So what the S stands for is same. In other words, whatever this sign is, I'm going to have the same sign there. Just like this. Whatever that is, same sign there. The O stands for opposite. In other words, whatever this sign is, I'm going to change it to the opposite sign. Whatever this sign is, I'm going to change it to the opposite sign. AP stands for always positive. In other words, it doesn't matter what happened up here, this back sign is always going to be a plus because it's always positive. Now what I have to do is I have to fill in the slots. Not too difficult to do, because what I'm going to do is take the cube root of this, which is A, and fill it in the front slot. And the same thing is going to happen here. Cube root of this goes here. Then I'm going to take the cube root of this back term, which is B, and it's going to go here and there. Now what I'm going to do to fill in this front slot, I'm going to take that term right here and I'm going to square it. So A squared goes here, and then A squared goes here. Then I'm going to repeat that idea, and I'm going to take this one and square it. That goes in the back slot. So B squared goes here. B squared goes here. And then to fill in the middle, what I'm going to do is multiply these 2 together, AB. And multiply these 2 together, AB. And that is what gives me my pattern for the sum and difference of cubes. Let me get that out of there. Now we know that means opposite and always positive. This, my friends, is the pattern for sum and difference of cubes. Yes, you have to have that pattern memorized. This is the only one that you have to have memorized, though. And to help with the memorization, remember, binomial, trinomial, cube of soap fills in the signs. S for same, carry that sign over, carry that sign over. O is for opposite, whatever this is, change the sign. AP is for always positive, doesn't matter what happened up here, make it a positive in the back. Now, binomial, trinomial. Cube root here goes there. Cube root here goes there. Square this for the front. Square this for the back. Multiply the 2 together to get in the middle. Now, you may be thinking, now hold on a second. When I multiply A times B, I get a positive AB. How come that's negative? Same thing here. A times negative B is a negative AB. How come that's positive? Remember, these signs are here because of this cube of soap. Memorize that pattern and just fill it in based on the memorization. Now let me prove to you that this is in fact the correct way to factor it. Remember, if you see this, you know you're going to do the extended distributor property. And you're going to say A times A squared is an A to the third. You're going to say A times negative AB is a negative A squared B. You're going to say a times b squared is an ab squared. And then you're going to pick this guy up, and you're going to say b times a squared is an a squared b. And then you're going to say b times negative ab is a negative ab squared. And then you're going to say b times b squared is a b to the third. And now I'm going to combine in my like terms. My negative a squared b combines with this one, but they cancel. My ab squared combines with this one, but they cancel as well. And all that I'm left with is an a to the third plus a b to the third. Which, if you notice, this was that factorization that came from an a to the third, b to the third. So I know that, yes, this is in fact the correct way to factor it. Let's check this one. A times a squared is a to the third. A times ab is an a squared b. A times b squared is an ab squared. Negative b times a squared is a negative a squared b. And negative b times ab is a negative ab squared. And negative b times b second is negative b to the third. And when I combine those like terms, a squared b combines with this, but they cancel. ab squared combines with this, but they cancel. And I'm left with my a to the third minus b to the third. And like before, notice this is this factorization, which that is the factorization for this, which is exactly what I ended up with. So yes, that is in fact the correct way to factor it. I also want to point out that I always tell you just keep factoring, factoring until you can't factor anymore. In other words, look at this and say, is there anything more that I can do with this? You will not be able to do anything more with this. This is a pattern. Once you fill in these parts, you are done. It won't factor anymore. I promise it won't factor anymore. So fill in that pattern and call it quits. And again, yes, you have to memorize it, but it's only one that you have to memorize. Now, let's practice it with a little bit. I've got two examples for us to look at. Notice in the first example, I'm always going to look first to see if there's anything common that I can divide out, and there is not. But I'm looking at this going, I wonder if this is a sum of cubes. This is a cube term. The cube root of z to the third is z. This is a cube term because the cube root of 1 is just a 1. So this is in fact a sum of cubes. That tells me that I'm going to do a binomial and a trinomial. Now I'm going to fill in my signs first because that's the easiest way to go. Remember, cube of soap. S stands for same. So whatever this sign is, I'm going to carry it over as the same. O stands for opposite, so whatever this is, I'm going to make it the opposite. And AP stands for always positive, so this back one is always going to be a positive. Now I'm going to fill in my slots. This slot comes from here. The cube root of this goes here. This slot comes from here. The cube root of this goes here. Now to fill these in, I'm ignoring this, and I'm just going to play with this one now. Square this for here. Square this for here. And 1 squared is simply a 1. And now to fill in the middle, remember I'm going to multiply these two together. Z times 1 is just a z. So here it is. There's my factored form. And yes, you're going to look at this and you're going to say, can I take that any further? You're not going to be able to take it any further because you'll try to set up that double parentheses. You'll try to split this as a z and a z. This as a 1 and a 1. You'll try to make this same sign, both minus. But when you FOIL this, out here you'll get a negative z. In here you'll get a negative z. That's a negative 2z, and I have a negative z in there. So this will not factor any further. That's as good as it gets. Remember, sum and difference of cubes. Fill in the pattern. Call it done. You can't do anything else with it. Now when I go to check this, z times z squared is a z to the third. Z times negative z is a negative z squared. Z times 1 is positive z. Now pick this guy up. 1 times z squared is z squared. 1 times negative z is negative z. And 1 times 1 is 1. And check this out. Negative z squared cancels. Z and negative z cancels. I'm left with a z to the third plus 1, which is exactly how I started. So I know that that's the correct way to factor it. All right, let's try one more. Now notice it feels like this is a difference of cubes. I'm going to check that out, and notice there's nothing common that I can divide out. I always do that first. Nothing common I can divide out. So let's see if this is in fact a difference of cubes. Most definitely the cube root of y to the third is y. Most definitely the cube root of x to the third is x. This 8, what's the cube root of 8? 2. 2 times 2 is 4. 4 times 2 is 8, so it's a 2x. So I know that yes, this is a difference of cubes. So I'm going to set up my binomial and my trinomial. I'm going to fill in my signs with that cube of soap. S stands for same, so I'm going to carry that sign over. O stands for opposite, and AP stands for always positive. Now I'm going to fill in my slots. The cube root of this goes here, so my 2x goes right here. The cube root of this goes here. And now what I'm going to do to fill all this in is I'm going to square this. Here's where people make a mistake. I'm squaring this. I'm squaring the entire 2x. All of that 2x gets squared. Not just the 2, not just the x, but the entire 2x. 2 squared is 4. X squared is x squared. So this is not a 2x, it's not a 4x, it's not a 2x squared, it's a 4x squared. Be very careful about that because that's where most people make their mistakes. Now, remember, I'm going to square this for the front slot, I'm going to square this for the back slot, and then I'm going to multiply the 2 together for the middle. And I'm not going to worry about the sign, that's why I filled in those signs first with my cube of soap. So here it is, this is the correct way to factor it. And I can check to make sure it's right. Remember, when I check it, 2x times 4x squared is an 8x to the third. 2x times 2xy is going to be a 4x squared y. 2x times y is going to be a 2xy squared. Negative y times 4x squared is going to be a negative 4x squared y. Negative y times 2xy is going to be a negative 2xy squared. And then negative y times y to the second is going to be a negative y to the third. Notice these are like terms that will cancel. These are like terms that will cancel. And I'm left with an 8x to the third minus a y to the third, which is exactly what I started with. Please understand though, folks, this and this, they're only the check. These are not the answers. The answers are the factored form here and the factored form here. So, hopefully you're seeing with that sum and difference of cubes, yes, it is a pattern that you definitely need to memorize, but it's only one pattern to memorize. Cube of soap allows you to fill in your signs. You've got a binomial and a trinomial. Cube root goes here. Cube root goes here. Square this for the front slot, square this for the back slot, multiply the 2 together for the middle. And then like I said before, be very, very careful if you've got more than just one single number or variable in here. When you square it, square the whole thing. Square the 2, square the x as well to give you the right term. I hope this helps. Have a fantastic day.